All right, today we're going to be working on target 4.1, which is learning how to calculate potential and kinetic energy. Now, if you recall, there's two kinds of energy, potential energy and kinetic energy. Now, potential energy is simply known as stored energy, and if we know, for example, how high something is off of the ground, we can actually calculate how much stored energy it has. And technically, this would be gravitational potential energy. So I have a formula, m times g times h. So the m simply stands for the mass of the object in kilograms. G stands for gravity's acceleration. So on Earth, gravity's acceleration is 9.8 meters per second squared. And then lastly, in order to calculate the potential energy of an object up high, I need to know h. H is simply the height in meters. So if you take a minute, let's look through the first problem. A 3-kilogram book sits 1.5 meters off of the ground on a bookshelf. First of all, how much does the object weigh? Now, if you recall from our previous physics, when I take the mass times the gravity on Earth, I actually get an object's weight in newtons. So very simply, all I'm going to do is I'm going to take mass times gravity. 3 kilograms is my book's mass, and that object has 9.8 meters per second squared of gravity. Now, if I multiply those two numbers, that's going to tell me how much the object weighs. So 3 times 9.8 gives me 29.4. Now, if you take a look, a kilogram times a meter per second squared. No units cancel out, so I'm going to get a kilogram times a meter per second squared. And if you recall, that is what we call a newton. So a 3-kilogram book has 29.4 newtons of weight. Now the second thing I need to do is I need to calculate how much stored energy it has. So PE equals mass times gravity times height. And again, mass times gravity is simply the weight in newtons times meters. So we know we have 29.4 newtons of weight. And in this example, I have 1.5 meters of height. So if I take my mass times my gravity times my height, 29.4 newtons is how much the book weighs, and it is 1.5 meters off of the ground. So it's going to have 44.1, and my unit is a newton times a meter. So it's a newton dot meter, and if you recall from our previous lesson, a newton meter is equal to what we call a joule of energy. So this book has 44 1/10 joules of stored energy up high. Now let's go to a problem where we aren't going to do it step by step. How much potential energy does a 68 kilogram person have that is 4 meters high on a diving board? So 68 kilograms is my mass, my height is 4 meters. Now first thing is I'm going to write my equation. Potential energy is mass times gravity times height. So in this problem, a 68 kilogram person is going to be, we're going to multiply their mass times gravity. Gravity again is always 9.8 meters per second squared. And then lastly, I'm going to multiply by how high off the ground is this person. I'm going to multiply by the 4 meters. So 68 times 9.8 times 4 gives me a big number. I get 2,665.6. And if you take a look, what would my units be? Remember, a kilogram times a meter per second squared is a newton, and a newton times a meter. So I'm going to get 2,665 newton meters or joules of stored energy. Now let's switch gears and let's talk about kinetic energy. Kinetic energy, on the other hand, is energy of motion. So take a second. If I'm going to calculate how much kinetic energy an object has, it's how much moving energy does it have. So I have a different equation. KE equals half of m times v squared. So the m simply stands for the mass of the object. V is the velocity or the speed. And when I do v squared, that simply means I need to square the speed. So velocity squared. And when I square velocity, I simply take velocity times velocity. I have to multiply the number by itself. Now that doesn't mean multiplying by 2. Square means I take If my number is 5, I take 5 times 5, not just 5 times 2. So let's look through the steps. If I'm going to figure out how many joules of moving energy an object has, I need to know the mass of my object and its velocity. I put my numbers into my formula. Now, one of the things you need to keep in mind is the order of operations. If you remember, please excuse my dear Aunt Sally, there is an order that you actually have to do your calculation. So in this particular problem, we do have an exponent, we have multiplication and division. So it's important, highlight number 4, you must square the speed first, multiply it by itself, because you have to do the exponent first. All right, that's a rule of math, the order of operations. The more complicated operations go first. Now once I square the speed, I can then multiply by the mass, and then I divide by 2. Now let's look at 2 examples. A 1 kilogram ball is thrown into the air with a speed of 30 meters per second. So take a second. 1 kilogram, of course, is my mass. A speed of 30 meters per second, of course, would be my velocity. How much kinetic energy does the ball have? So I'm going to circle that. So keep in mind, you got to be careful when you do word problems which equation to use. So in this case, I'm going to do kinetic energy. So if I'm going to figure out how much moving energy my ball has, I'm going to take half of mass times velocity squared. So write the equation first. Secondly, I'm going to plug my numbers in. My mass is 1 kilogram. My speed is 30 meters per second. Now stop there and put that in parentheses. The speed needs to be squared. So I'm going to put a parentheses around my speed to remind myself I squared the 30. Now I have my speed in place, I have my mass, so now I just have to do my calculation. 30 squared is 30 times 30, not 30 times 2. 30 times 30 is 900. Now I'm going to actually kind of go forward. So half, I still have 1 kilogram. 30 times 30 is 900. If I squared m, I get m squared. If I square s, I get s squared. Now from here, I then have to multiply. 900 times 1 is 900. And then I simply take that by 2, divide it by 2. So 900 divided by 2 will give me 450. 450 what? In this case, I would get 450 kilograms dot meter squared second squared. That's pretty complicated, so we're just going to say that equals a joule. So a kilogram times a meter squared second squared is equivalent to a joule of energy also. So basically, if I have 450 joules of kinetic energy, the second question is, how much potential energy was there needed to get this? So keep in mind, kinetic energy comes from potential. So you need 450 joules of potential energy to get 450 joules of kinetic energy. The law of conservation of energy says I can't gain or lose any energy in that process. Now let me scoot this over so you can catch the end of that problem here. Now lastly, in the last problem, you're going to compare the mass and velocity of a boy and his father as they run. I'm going to stop here. I'd like you to set this problem up, and when you see me the next time in class, you're going to check your answers against mine. Now please notice on the back side there is an independent practice sheet. Here are your 2 equations. So keep in mind a couple things. G always is 9.8 meters per second squared when you're calculating stored gravitational potential. And keep in mind, if you're finding moving energy, kinetic, you always need to do the square first before you do any of the other parts of the equation. All right, that's all for today. Hopefully you have a grasp of how to plug your numbers into the both potential and kinetic energy equations.